Greetings, this is Miss Jackson. I'm going to finish the Unit 2 test review that I've sent home. I'm going to work out problems 9 through I think 12 on this video. Let's start with number 9. And I see right away a number line. And our first class rule on my class rule list is label all number lines. We are going to work with number lines for almost everything this year. The only thing that we don't really use number lines on are shapes, but maybe we'll find a way one day. The first thing we need to do, before I even solve this, I'm going to look at these answer choices and figure out what are each of these intervals worth. Because on a number line, we don't count the lines. If we do that, it's going to throw us off. We count the spaces. The spaces are what hold the value. Well, I know from here to here has a value of 5. My intervals are going to be smaller than 5. Let's see if we count these by ones. 1, 2, 3, 4, 5. That's perfect. It gets us right to from 0 to 5. Each of these spaces has a value of 5. I like to have the kids label number lines when it's not too difficult or messy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. This one may actually be too tightly spaced to label it and keep it organized, so they may not be able to label this one. That's okay, as long as they know what those spaces are worth. So let's read the problem. There were 21 horses in a field. Some of the horses went in the barn. There were 9 horses left in the field. Which number line represents one way to determine the number of horses that went in the barn? The first thing we need to do is write an equation. If we can pull the equation out, then we just have to find the number line that matches the equation. My equation would look like this. 21 minus something, I don't know what, it just says some horses went in the barn, equals 9. 9 is the number of horses that were left. So let's see what we can do. This first number line goes up to 21. That's perfect. That's the first part of this equation. But from there it adds 9. We're not adding 9 on here. The number of horses that went inside can't be 30. That's not reasonable. We could not have more horses go in than were in the field to start with. So A is not an option. B just goes to the number 9. It doesn't represent the equation at all. And secondly, 21 minus 9, if I were to say, okay, let's plug a 9 in here. 21 minus 9 is not 9. So let's see if I can erase that. B does not work. C. My first arrow goes from 0 to 21. That represents the horses in the field. That's good. And then it goes back a distance. And going back on a number line represents subtraction for now. Later, it might represent division, depending on how it's going back. But for now, we're just into addition and subtraction. And it's going back and it's stopping on the 9. Well, that's pretty good because this is how many horses are left right here. So that's what it should look like. However far this top line went back, that would be the number that fits in here. Let's see, how far did that go back? $12. Hey, if I put a 12 in there, 21 minus 12 is definitely 9. C is looking good. Let's take a peek at D and just make sure. D has a arrow that goes from 0 to 21. That's perfect. Oops, the next addition still going, the next arrow goes forward. That represents more addition. It's trying to tell me that 34 horses went inside. Well, that's not reasonable to say 21 minus 34 is 9. So D can't be our answer. At that point, we're left with option C. Let's look at D. Valerie collected seashells. Each day she was at the beach. She collected, let's see, 57 seashells on Monday. I'm going to represent this here with a model. She collected 41 seashells on Tuesday, and she collected 133 seashells on Wednesday. Let me fix what I drew in this box on Tuesday. Will that go away? Yes, it will. Okay, Tuesday was 41 seashells. Okay, let's read the rest of the problem. What is the best estimate of the total number of seashells that she collected? Well, Estimate tells me I have to round these numbers first. I'm going to look at my answer choices because the problem doesn't say round to the nearest 10 or round to the nearest this or that. It just says round. So let me take a peek. It looks like they've rounded everything to the nearest 10 here because there are 10s in all of these numbers. So that's what I'm going to do. 57 would round to 60, 41 to 40, and 133 to 130. Now it wants to know the total number of seashells combined. So we would add that together. 60 and 40 is 100 plus 130 is going to be 230. That's answer choice A. 11 says the table shows the number of shirts 3 stores sold yesterday. How many more, and that's going to be a very important phrase this year, how many more shirts did Just Perfect and Shack Shop sell than Ridin' and Rollin'? Okay, the first thing I need to do is think about this problem. It says, how many more shirts did Just Perfect and Shack Shop sell? So we're going to have to combine Just Perfect and Shack Shop's number of shirts together. 66 plus 54. Let's do that with the standard algorithm. 120 is how many they sold combined. How many more did they sell? So if I were to make a model of this, here is, I'll just put their initials, Just Perfect, Shack Shop sold a total of 120. Riding and Rollin' sold 87. What we want to know is the difference between the two, because that's what how many more means. How many more means we're making a comparison. When we compare, we're finding a difference. Difference means subtraction. To subtract this, I'm going to do 120 minus 87. All right, 33, and here it is. Now I should check my subtraction with addition, and I can do that like this. Take the difference, which is 33, add my smaller part, 87, and I should come up with 120, hopefully. 7 plus 3 is 10, 8, 3, and 1 is 12. That gave me that 120 back, so that math is correct. One thing they have to be careful about is if it's saying this and this combined, like Just Perfect and Shack Shop are combined. So we have to add those and find that total first before we can continue with the rest of the problem. Now, problem 12 says, let's move this thing up. Jasmine baked 183 chocolate cupcakes, 204 vanilla cupcakes, and 75 strawberry cupcakes. How many cupcakes did she bake combined? Well, combined means put together. Let me draw a quick model. The chocolate cupcakes, there were 183. For vanilla, we had 204. And for strawberry, we had 75. We want to combine those, put them together. So let's work an addition problem. Some kids try to stack multiple numbers together at once. It usually doesn't go very well because things get off and shift in a weird way. I would suggest adding two numbers together and then tacking on the third. So 183, 204. 4 minus 3 is 7. 8 minus 0 is 8. 1 plus 2 is 3. Then add to that 75. 7 and 5 is hopefully still 12. 1 and 7 is 8. 8 and 8 is 16. And then 3 plus 1 is 4. Let's hope that's an answer choice. There it is. Really quickly, before the kids come back from specials, I'm going to show you what this would look like if you represented it as a strip diagram, because that's one model that we use a lot in here. To represent this as a strip diagram, we draw a rectangle, we divide it in half. Strip diagrams have two components to it. The top always shows us the total if we know it. In this case, we don't know it, so we're going to represent the total with an X. Sometimes they'll use a question mark instead, but I've seen both, so either works. The bottom component, those are the parts that make up the total. In this case, it would be the 183 cupcakes, 204 cupcakes, and 75. On a strip diagram, if we have all the bottom parts, but we're missing our total, what we have to do to solve that is add the parts together. All right, we're going to stop there. If you have any questions, please feel free to reach out to me. I'll be happy to help you. Thank you so much.